We have, oh, you can see,
Yeah, I can check.
okay, 200 hours, 100, this is the problem. Okay, the steam boiler is working with a 80% efficiency, right?
60% low.
And 60% upload, right? Okay, if we go to the equation, we can see that 1 bhp produce 34.5 pound of steam per hour, right? So I'm gonna have E is going to be equal to 200 HPV multiplied for, we know that 34.5 per hour, right? Okay, well, I can explain you simple, or I explain you like, this is the mathematical way.
Yeah.
Okay. And this by the efficiency
85.
and the load, 45, right? And
65. 60.
oh, 65.
60, 60, 60.
Oh, 60.
60. Yeah, 60. So, minus.
No, it's okay. No, really. And 5. Okay. Well, it's the same. You put 6 or 60.
6. Yeah, it's okay.
Okay. That is 3,500
90.
pounds per hour of the steam, right?
Yeah.
So right now we have this. Now we want to know the blowdown. For the blowdown, we need to know the cycle of concentration. The cycle of concentration is gonna tell us how many times the water has to go into the system before we have to discharge this water. Okay? In this case, the cycle of concentration is pi. The equation says that the blowdown is going to be E times 3,519, right? It's going to be the cycle of concentration 5 minus 1. And it's going to be 879.8 pounds per hour. So right now we have this too, right? Well, we have this. It's important to know only this. Normally we're not gonna have a blow down here, okay? We put this here, but normally we're gonna have the blow down in the boiler. Okay? So let's check this out. Okay. And then we have E, we have the blow down. So how much is gonna be the feeder? How much is gonna be this? Okay. We have this one, we have the pounds per hour of steam, and we have the pounds per hour from the blowdown. What is gonna be here?
The total, I don't know.
the feeder is gonna be E plus the blowdown. You can see that you don't create anything. It's the same flow. What is going in and go out is gonna be here. Okay? Any question?
Yeah.
No. So here it's gonna be equal to 9.8 pounds per hour plus 3,519 pounds per hour. Okay? That's gonna be equal to 5,000.
4,398.8.
Okay. In this case, we don't have a condensate return. What happens if we have a condensate return? Okay, let's gonna do this equation. What is gonna be the makeup? Somebody can tell me what is the makeup?
Sorry?
What is the makeup?
What is the makeup? Is the water that you needed to put in the system.
Yeah. And then it's the water that you need to put again in this system. Because you lose water here and you lose water here. Right? Okay. I'm gonna put two situations for the makeup. In this situation, in one situation, the condensate return is gonna be equal to 0, right? And in the other one, the condensate return is gonna be equal to, let's say, 1,000 pounds per hour. Okay? Okay. We have this one, right? So we can say that feeder is equal to the makeup plus the condensate return, right? These two go to this one, right?
Yeah.
So if we want to know how much is the makeup is going to be the feeder, right? Less minus the condensate return, right? Like I say, we have two cases. Case 1, case 2. Okay? In case 1, the make and return is equal to the feed. Yeah?
Yeah.
And the second one, the make and return is equal to, we were
4,399 minus 1,000.
sorry. And the makeup is gonna be 3. It's gonna be less. You're gonna save a lot of money.
So we
Okay.
need the condensate return.
What?
We need the condensate return.
Yeah. They have to tell you how much is gonna be the condensate return.
But what would 0.20 point water make up? What's that the amount
Person?
on the slide?
They're going to tell you the pounds per hour.
Oh.
Okay. Let's go to talk about the steam trap. Okay, sorry. This is so important that you understand this part. It's gonna be easier if you know that the balance, what's go in, go out. If you have, doesn't matter the drum. If you have two lines, and you have if and you have B, I don't care. And this is L, and you have the flow in this direction, right? L is going to be E plus B, right? That's the conservation. Right? If you know that rule, it's gonna be easier for you. Okay. Okay, a steam trap. Why we use the steam trap? Like I said before, in this point, we use the steam trap. We have the steam in this point. But we want to be sure that the quality of the steam is good, right? So, in this point, we put the steam trap with the main purpose of increase the quality of the steam, and in the same time take the water of the steam and take one part of that liquid and take it here, right? When you make the design, the engineer that makes the design have to tell you if the flow, the trap is gonna take the 20% of the rate of the steam, and you know how much is gonna be the flow. Okay. It's important to have a plan on maintenance in the steam trap. Surveys have shown that major industry plants with a regular steam trap maintenance program show an average of 10% of all the steam trap to be inefficient. What happens if the quality of the steam is low? You're gonna have a lot of water in the steam, so you're gonna increase the rate of corrosion in the pipe. Okay. There is three type of inspection in the tram: the visual, the thermal, and the acoustic. Okay, and this is the final slide. Okay, when you're gonna store out of service a boiler, there is two methods. There is the wet layup and the dry layup. The wet layup refers to the boiler being completely droplet with chemical treatment water, and the dry layup refers to removing all the water, completely drying all water side surface and maintaining a dry condition during storage. The wet layup generally is for short-term storage when boilers need for online service quickly, require in areas of high relative humidity. The dry layup generally is for longer term storage, require if freezing condition exists. Not recommended for areas with high relative humidity. Well, this is all. This is my mail. If you have any questions, then send me a mail. So, this.
Do you guys have any questions so far?
Do you have any questions?
So,
Thank you very much for this opportunity.
So I know got something to do, what you already told me. Basically, took out presentation 2, Seneca College give a souvenir for your effort. Thank you for sharing some experience. For sure, I believe, all these, you believe the experience you share is very valuable, right? Maybe give him one more some encouragement. Thank you so much. Your slide, you're going to give it to me, I'm going to post it.
Oh yeah, but I have this slide a little shorter. I have to complete the slide.
No problem. Well, we talk. Maybe you send to me,
Okay,
you know, when you
tomorrow I
finish.
will
Or,
show you.
yeah. Okay. It's not much. Next week I'm going to review some water balance, as I mentioned. Okay. The major, you know, the main reason I invite you is showing you the concept. Okay. Steam boilers, you know, some designs, different functions. So hopefully you guys grab the concept. Starting next week, I'm performing the water treatment for steam boiler, and I will do the calculation for water balance. We're going to do the problem. It will be important.